In this lesson, we will analyze a sample satellite image dataset from one of our research projects called WIFIRE, and we'll use the NumPy library in this analysis. WIFIRE is an integrated system for wildfire analysis which is capable of handling changing urban dynamics and climate. The system integrates networked observations from a variety of sources, including heterogeneous satellite data and real-time remote sensor data. It then processes all these data using computational techniques in signal processing, visualization, predictive fire modeling, and data assimilation in a scalable way. The result is a system capable of monitoring weather patterns and other factors to help predict a wildfire's rate of spread. You can read more about WIFIRE at wifire.ucsd.edu. By the end of this video, you should be able to describe what satellite image data is and how it helps fighting wildfires, and apply basic methods in NumPy for image processing. In this lesson, we'll go over a notebook that uses a satellite image from landfire.gov that can be used for analysis of the Earth's surface. It is very common for any earth science application to include an analysis of visual graphs in the form of maps, photos, or satellite imagery, as seen in this image. Many other data science applications will also involve a form of image processing. We need to have a basic knowledge of image formats and how to work with images in Python to get started in this vast field. So before we switch to our notebook for further practice, let's review a few key points on image processing and earth science applications. Simply speaking, we can say computers store images as a mosaic of tiny squares. This is like the ancient art form of tile mosaics, or the melting bead kits kids play with today. If these square tiles are too big, it's hard to make smooth edges and curves. The more and smaller tiles you use, the smoother, or as we say, less pixelated, the image will be. This sometimes gets referred to as resolution of the image. Please note that vector graphics are a somewhat different method of storing images that aims to avoid pixel-related issues, but we'll set those aside for now. Even vector images, in the end, are displayed as a mosaic of pixels. Each of these squares is called a pixel. Each pixel is only one color defined by a set of numbers. A simple way to describe each pixel is using a combination of three colors, namely red, green, and blue. This is what we call an RGB image. In an RGB image, each pixel is represented by three 8-bit numbers associated to the values for red, green, and blue, respectively. The combination of these three will in turn give us a specific shade of the pixel color. Since each number is an 8-bit number, the values range from 0 to 255. For example, a yellow value can be identified by 255, 255, and 0 for RGB, as we see in this diagram. If all three values are at full intensity, that means they are 255, it shows as white. If all three colors are muted or has the value of 0, the color shows as black. Since each value can have 256 different intensity or brightness value, it makes 16.8 million total shades. In Python, RGB images are ND arrays of shape, height times width times 3 for each RGB layer. Now that you have a basic background in how color images are stored in Python, we can look at WIFIRE data in more depth. Over the next video, we will go through a notebook in which we start by importing a high-resolution image from the NASA satellite Landsat. We will mainly use NumPy functions, filtering techniques, and some domain earth science knowledge to analyze this image. So how do we use the results of this analysis in predictive fire modeling in the end? We will make this fuel dataset one of the many other datasets we use for fire modeling. We see in this diagram how we can make many real-time analysis results a part of the fire modeling. Once integrated with other sources of information, such better and automated fuel models can lead to more accurate results. We provide you a short video that further explains how all these datasets are integrated and analyzed using data science as the next video in this lesson before we start with our notebook. Please feel free to skip it if you would like to jump ahead to the notebook.